Okay, the language of polynomials. So what we're going to be doing in this video is we're just going to be talking about polynomials, what they are, and all the different things that we can have to do with them, okay? So let's start off by describing or explaining what is a polynomial. Now a polynomial is an expression of the form p of x is equal to a n x to the n plus a different constant, to 1 less than the power, plus a third constant to the some x power, all the way down to a constant term. Okay, so basically what this is saying is a polynomial is a expression. So for example, if we had p of x is equal to x to the power of 5 plus 3x to the power of 4 plus 2x to the power of 3 plus, let's say, x plus 2. Okay? So something like this. This is a polynomial where all of the powers of the x terms are whole numbers, whole positive numbers, or 0, as we can explain with the constant term. Well, there's technically an x to the power of 0 sitting there, but we know that x to the power of 0 is equal to 1, and therefore that just makes that whatever the constant term is, or the coefficient is. A polynomial function is a function that can be written as a polynomial, so p of x is equal to this is a polynomial function, and AO is the constant term as I just expressed, also the value when x is equal to 0. So if I substitute, let's say let x be equal to 2, when x is equal to 0. And then if we do our substitution, then that is equal to 2, because all of the terms will cancel out. And that's a really key fact. It's going to be coming up a lot. Now, in a polynomial, we have a bunch of different terms that we can talk about. So, to begin with, let's talk about the leading term. Now, the term with the highest index with non-zero coefficient is called the leading term. Okay, so in my first one up here, this x to the power of 5 is the leading term. Okay, so the leading term, if you're asked to find what the leading term is, you just write the leading term is equal to x to the power of 5, because it's got the biggest constant. Its coefficient is also called the leading coefficient of the polynomial. So in this case, the leading coefficient is 1, and its index is called the degree. Okay, so if I ask you what the degree of the polynomial is, okay, it's just whatever the highest power is. Okay, in this case it is 5, so the degree is 5. A monic polynomial is a polynomial whose leading coefficient is 1. So in this one up here, this is a monic. It's monic because the leading coefficient is a 1. So we could put a 1 there, but we don't need to because we know that that represents an x to the power of 5. So that is a monic polynomial. Now, we do have some specific types of polynomials that we can talk about. So the zero polynomial, so let's say we have some z to the x, that's just equal to 0. Okay, so the zero polynomial is just when the polynomial itself is 0. It is a special case, and it is constant 0, but has no leading term, leading coefficient, and most importantly, no degree. So it doesn't have any terms, any coefficients, or any degrees. Okay, so that one's just equal to 0. Now, a constant polynomial, so c of x, is equal to some value. Okay, so for example, we could have 5. C of x equals 5. We could have c of x is equal to 10. C of x is equal to a half. You get the picture. Let's pop a minus in front of that one. But the constant polynomial is just ones where it is the constant term. So apart from the zero polynomial, which is also a constant polynomial, the degree is 0, and are equal to their leading term and leading coefficient. Okay, so leading term is, well, in the first one it's 5, for example, which is the same as the leading coefficient, which is also 5, okay, because there is no change with that. And it's also the same as the constant term. So we asked you what the constant term is, it's just the terms by itself again. Now a linear polynomial, so let's say L of x is equal to mx plus b, for example, because we know that is a polynomial of degree 1. It'd make a straight line if we were to sketch this. Constant polynomials are not linear polynomials, okay? So a constant polynomial, even though it would make a line, so like let's say if we had c of x is equal to 5, okay, it would be a line that goes across here, and that would be 5 here. A linear one is usually a line that goes straight up like this, or like this, something like that. So these are linear, and that one is not. Okay. Now the degree of these ones is equal to 1. And when we are talking in the polynomial topic, we're mainly concerned with finding linear factors of polynomials. Because finding normal factors is trivial, we only want to find the linear factors. Okay, so in this case, when we factorize something, we want all of our factors to be in the form where there is only one x. So for example, like 3x plus 2 or x minus 5 or something along those lines. Now the next one and the last one that's got a special name, or the main one we're concerned about that has a special name, is a quadratic. So quadratic of x is equal to, so ax squared plus bx plus c. Okay, and it is a polynomial of degree 2. And then a trinomial, I forget what it is. But like the idea is that, you can have 3, you can have 4, and you can have 5, and they're going to keep going up, and the degree is going to keep increasing. But these are the main 4 that we're concerned about. Okay, so an example of this one might be like x squared minus 5x plus 2, something like that. Now, when we've got these polynomials, we can actually add and subtract them from each other. So let's say we're going to add the linear factor, the linear polynomial of 3x plus 2, and we're going to add that to the quadratic polynomial of qx, which is x squared minus 5x plus 2. So what we can do is we can write lx plus qx. Okay, so if we're ever to find this, then what we're doing is we are essentially going to be substituting our values or our polynomials in replacement of those ones. So if Lx is equal to 3x plus 2, we can just go 3x plus 2, okay, plus x squared minus 5x plus 2. Okay, and then we can just put those ones together. So in this case, there's no x squared terms to be added together except for the 1, so we're going to leave that one. 3x minus 5x is minus 2x, and 2 plus 2 is equal to 4. And so there's the sum of the two. We can also subtract these, so we might go q of x minus L of x. Okay, so in this case, this one will be x squared minus 5x plus 2 minus, and I'm going to put this one all in brackets, 3x plus 2. Okay, and so we put that together, get x squared, we'll expand first, and then we'll put it together. So minus 3x minus 2, because it's negative that one, and then putting it together, we get x squared minus 8x, and then plus 0, which is just equal to that. Okay. Now, if we're talking about the degree of the sum and the difference, so if we're adding the two polynomials together, then the degree is just the maximum of the two. So, as we can see, the degree for this one up here is 1, whereas the degree for this one here is equal to 2. Okay, if we have a look at our sum, our degree is also equal to 2. And it's just going to be the maximum of our two polynomials. So you look at the two polynomials, you see which one has the biggest degree, okay, and then you just, when you add them together, the degree of the new polynomial is just going to be the same one. Now, sorry. If the degree is the same, okay, then the degree of p of x or q of x is going to be, so the degree of these two is going to be at least equal to, if not smaller than what you began with. Okay, so for example, if we were to subtract the two, okay, there's a potential that we would have the squared as our as our main factor, but there's a potential that we could not either. So if I had, let's go f of x is equal to let's say x squared plus 4, and g of x is equal to x squared minus 3x plus 2, okay? And then I said, okay, what's g of x minus f of x, okay? So we know that the degree of this one, so the degree is equal to 2, and we know that the degree of this one here of g of x is also equal to 2. So if I subtract the 2, what we get is we get x squared minus 3x plus 2 minus x squared plus 4. Okay, and I'm putting that together, or expanding it out I should say first. We get minus x squared minus 4, and now putting it together we're going to get, so the x squared and the x squared is going to cancel out. I'm going to be left with minus 3x minus 2, okay? And so in this case, the degree is actually the smallest one. Or it's actually a smaller value, okay? So it's either going to be the same, it's going to be less than, or it's going to be 0, okay? So there's no in between. So it can't be bigger, obviously. It can only be the same or smaller. So when you're adding together, it's going to be the maximum, and if they're the same, then it's going to be the minimum of the two. It's going to be at least that or smaller. Now we can also multiply our polynomials together, okay? So, if we have p of x is equal to x plus 2, we've got q of x is equal to, x squared plus 3x plus 4, okay? So there's some things to notice about this one. Okay, if we multiply these ones together, then the degree is just going to be the sum of the two highest terms, okay? So what that means is, if I have p of x times q of x, okay, what I could do is I could work them out. So x squared plus 3x plus 4, lots of, it doesn't matter which way I write these ones around because we know that it doesn't matter which way we have our multiplication around. But if we expand this out, we're going to get x lots of, hang on, let me do it this way. So we're going to get x times all of these, and we're going to get 2 times all of these. So we're going to get x cubed plus 3x squared plus 4x plus 2x squared plus 6x plus 8, which is equal to x cubed plus 5x squared plus 10x plus 8. And as you can see, the degree of this one is 3, which is the sum of the highest degrees in these ones here. So the degree is equal to the sum of the highest powers. And that's really important because if we asked you to find, the degree, so it said find the degree of x plus 2, x squared minus 3x plus 4, and then 2x squared plus 3x, and then maybe like an x to the power of 5 minus 3x, something like this. Okay, you could quickly do it by just adding up the degree of the highest powers in each of these. So in this case, we've got 1 plus 2 plus 2 plus 5. So 5, 6, 7, 8, 9, 10. So the degree in that one above would be equal to 10 because we're just going 1 plus 2. So that's the 1, that's the 2, and then the 2, and then the 5. Okay? So we just add up the sums of those. Now, if we ever wanted to, there is a value that we can multiply our degree in sum by. There's a polynomial we can multiply our a polynomial by, and it'll always give us the one back in return. So let's say we had p of x is equal to x squared plus x plus 3. Okay, what we've got is we've called it the identity polynomial. And the constant polynomial I of x is equal to 1, also known as the identity polynomial of multiplication, when we multiply it with any polynomial, we'll get the polynomial that we multiplied it into by back again. So, for example, I want to go p of x times I of x. I might erase that. And that's equal to x squared plus x plus 3 times 1. So that's just equal to x squared plus x plus 3. So I of x is known as the identity polynomial. It should be mentioned too that the identity polynomial for when you're adding or subtracting polynomials is when the constant polynomial, the zero polynomial. So if you add or subtract a zero polynomial to a polynomial, you get your polynomial in return. So that's the identity polynomial for multiplication, for addition and subtraction. When it's equal to 1 is for the multiplication. Okay, so two more things that we need to talk about. So two polynomials, p of x and q of x, are called identically equal. So often written as, so let's write identically equal polynomials. Now this is written as p of x, and it's this symbol here, which you may remember from congruency. So it's congruent, but it's exactly equal to q of x for all x, okay? So if two polynomials are identically equal, then the corresponding coefficients of the two polynomials are equal, okay? So we're going to have a look at an example of that. In fact, we'll have a look at an example of that right now. And we have got this one here. So we've got find a, b, c, d, and e if ax to the power 4 plus bx cubed plus cx squared plus dx plus e is equal to 2x squared minus 7 to the power 2, okay? So essentially, we're going to find out what we are looking for in this case. We're going to be essentially finding out what the coefficients are of the expanded term. So what we're going to do is we're going to start off with the the compressed, and we're going to expand it. So this is the same as 2x squared minus 7, lots of 2x squared minus 7 since it's the power of 2, okay? So expanding this out, we're going to get that time and that, and I'm going to get this one and this one, okay, as a quick reminder. So it's 4x to the power of 4 minus 14x squared minus 14x squared plus 49, okay? So working that one out, we're going to get 4x to the power of 4 minus 28x squared plus 49. Now you'll notice back in our original question, we're looking for essentially what is the values in front of the x's, or the constant term, okay? So what we can say is a is equal to, so if the two polynomials are identically equal, then that means that they have to have the same coefficients, okay? So we've worked out that in our expanded form on the left over on the right over here, okay, in front of the x to the power 4, we have a 4. Okay, so in our original thing, our original expanded form, where we're having to find our algebraic values, a must be equal to 4, because that's the same as the power of 4. So for the two sides to be equal, the a must be equal to 4. Okay, b, well, there's no x cubed term in the expanded form, so that must be equal to 0. C, okay, what's in front of the x squared? Well, that's minus 28. D, okay, so the x term, so there's no x term again, so that one's equal to 0. And last but not least, we have this e term, which is the constant term. And the constant term of this one is 49. So those are all of the a, b, c, d, and e that would make the equations the same. So if I was to put those back in, we would get 4x to the power of 4 plus 0x cubed plus, minus 28x squared plus 0x plus 49, like that. And that would be the whole polynomial. You don't have to do that, but because all we're doing is identifying it, but that is what it would be equal to if we were to substitute those back in. Now the last thing I want to talk about is polynomial equations in this video. And then I'm going to look at some factorizing some stuff. So if p of x is a polynomial, then the equation formed by putting p of x is equal to 0 is called the polynomial equation, okay? So basically what I'm saying is, if you have a polynomial like p of x is equal to, I don't know, x squared plus 5x, something nice and easy, then if you make the equation px equal to 0, which is also known as p of x is equal to 0, okay, whoop. So if you do this here, okay, you're creating what's called a polynomial equation. Now, the solution of a polynomial equation are called roots, okay? So if we were to solve this, we would be finding the roots of the polynomial. And we've actually done this quite a bit already at the start of the year, but we're going to be extending this out so that it is becoming a... So we're going to extend this out so that it's going to be a... what's the word I'm looking for? So that we can find them very easy, what the zeros are very easily. So those are called the roots of a polynomial, whereas the zeros of a polynomial function are the values of x, where the value of the polynomial is 0, okay? So it's a little bit of a sort of wordy thing. It kind of means the same thing. So if we make the equation and we're looking for the solutions, they're called the roots, whereas if we just look at the polynomial x squared plus 5x, okay, and we say to ourselves, okay, well, when is this polynomial equal to 0? We can say it's at 0 and at 5. Then those, or sorry, at negative 5, then those are called the zeros, okay, because we're not making it equal to 0. So when it's equal to 0, I'll write this down, when equal to 0, called roots, when by itself, it's called zeros, okay? And so our second example that we're going to look at, which is going to finish us off for this video, is we're actually going to factor the following polynomials and write down their zeros. Okay, so in this one, we're not actually going to be finding the roots because it's not equal to 0, but we're going to be finding the zeros because we're trying to find the values of x that I can substitute in that would give me a value of 0. Okay, so let's jump straight into this, and you could probably see where we're going with these ones straight away. Okay, so we've done ones like these already, or before. The only difference is that for the first one, there's just an extra, there's an x cubed term instead of an x squared term. So let's start with number A. So we've got x cubed plus 14x squared plus 45x, okay? This is equal to, well, let's take a factor of x out first. And that's going to leave us with x lots of x squared plus 14x plus 45. Now, what we can do with this one is we can factorize the right-hand side by using our monic binomial or trinomial factorizing. So we think to ourselves, okay, what are two numbers that multiply to 45 and add to 14? And we're hoping that x plus 5 and x plus 9 are the ones that are jumping out. Okay, because 9 times 5 is 45 and 9 plus 5 is 14. So what we can do is write, therefore, the zeros the zeros are x is equal to 0, x is equal to minus 5, and x is equal to minus 9. So this concept shouldn't be too foreign to you guys, because we have done stuff like this before with, you know, when we're trying to find the roots of the roots of a quadratic, or even some of the other stuff as well. This, excuse me. This is what we would say a instead of finding 2, we're finding 3 of these roots. Okay, so by taking that factor of x out, it leaves us with a quadratic trinomial, which we know how to factorize, and we just factorize it that way. All right, let's look at part B. So part B is x to the power of 4 minus, I think it was 100, minus 100. Okay, now this one's a bit easier, I think, because if you remember back to some of our rules, this one is a difference of 2 squares, because we've got, I could rewrite this as x to the power of 2 to the power of 2 minus, not 25, minus 10 to the power of 2, okay? So we can rewrite this one as x squared plus 10 and x squared minus 10, okay? So to find the roots for these ones, now, because we've got these x squared terms in there, there's going to be one of the sides which is not actually going to give us any zeros, because we can't actually mathematically solve it. However, the other side is going to give us all the possible roots that we need, okay? So, let's have a look. If I was to find the zeros of this one, so to find zeros, I'm essentially saying to myself, I want x squared plus 10 to be equal to 0. And I also want x squared minus 10 to be equal to 0, okay? So if I have x squared plus 10 equals 0 and x squared minus 10 equals 0, I can solve both of them. And what you'll notice is on this side, if I move the 10 across to the other side, we get this negative value. We can't find the negative of a or we can't do the square root of a negative. So we're going to move over to this side, just focus on this one. So x is equal to 10. Sorry, x squared is equal to 10, which means that x is equal to plus or minus the square root of 10. So therefore, the zeros are at x is equal to root 10 and x is equal to minus root 10. Okay? And that's it. That's all we need to do. So it's something that we've done before, nothing too hard, and we're going to leave it with that for our first part of polynomials, so our second extension topic. So with that being said, we're going to move on to the graphs of polynomial functions, which will be exercise 10b. But the exercise 10a, what we've done now, it's, as I said, it's nothing that's too out there, it's nothing that's too wild. And it's an easy way for us to step in and to start looking at polynomials, particularly when we have to do some tricky stuff coming up. So with that being said, we're going to leave that video and cut it there, and I'll talk to you guys in the next one.